All right, so now this is a big day because this is the beginning of trig for you. So trig is short for trigonometry, and that is the study of right triangles. Study of right triangles. So I really debated whether I wanted to do video notes or just do them in person, but because I have kids that have Wi-Fi issues and because we're going to be at school, I don't trust it. So I'm going to go ahead and do this. Okay. So trigonometry is the study of right triangles, and this is where it comes from. So what's cool about right triangles is that it's very easy to make similar triangles. Okay. So if you have a right triangle like this, um, well, first of all, just note that if you have a right triangle, okay, we study this, and what we study are the ratios of the sides, because if this is an example of, say, like, let's say this is 30, okay, what we know is that these sides have very specific ratios. This happens to be a special triangle. So, for example, on a special triangle, the ratio of this side would be, if this is x, this would be root 3x, and this would be 2x. And this is always the case. So what we do is we can study these right triangles, and you can actually, it's funny because when I went to school, we used to have to look up in charts. So we used to have to look up in charts the trig values, say like the sine, cosine, and tangent. Okay. And trying to figure out how I want to say this. Basically, trig is the study of right triangles. Okay. And the reason why we study them is because they're very unique in that they have the specific ratios. Like any particular right triangle, these ratios are going to be defined if you know this angle. Okay. If you know this angle, whatever it may be, 42 degrees, for example, we know what the ratio of the sides is going to be. Okay, and that is really the study of trig. So we have names for these ratios. Okay, there are 6 main ratios, but there's 3 that we're going to talk about right now. Okay, we're going to label, we're going to be looking at the right triangle like this. Okay, and you have to stand at a specific place. Like you have to decide, are you going to stand at this angle? Or are you going to stand at this angle? Okay, so I am going to, for this particular example, I am going to call this angle, we often call them Greek letters, so I'm going to call it theta, just so you know. Theta, okay? Now, imagine you are standing here and you are looking. So your eyeball is right here, okay? That's your eyeball. You are looking this way. We're going to call this side A, this side B, and this side C, okay? So when we are looking at these ratios, okay, there are 3. The ones we're going to start with the beginning. And the first one is called sine. And sine is abbreviated with SIN. It's not sin, it's sine. Okay. You always have to put the angle. When you find the sine, you're finding the sine of an angle. So you need to have that angle, whatever it is, you're telling the person where you are standing in this triangle. That is equal to the opposite. By the way, that theta is like an x. It's a variable. Opposite over hypotenuse. Okay? So in this case, you can always find the opposite side because it is the one that you can draw an arrow to. Boom. So the opposite over the hypotenuse is B over C. That is the ratio, B over C. Okay? The next one is going to be cosine. We represent the cosine as COS. Again, We're going to stand here, and the cosine is adjacent over hypotenuse. Hypotenuse. Or you can find the adjacent. It's not the opposite, and it's not the hypotenuse. It's the one that's right next to you that forms, it's one of the rays of the angle that you are at, and it's not the hypotenuse. So adjacent is A over the hypotenuse C. The last one we're going to talk about today is tangent, which is represented with the TAN. And the tangent of theta, if I'm standing here, is we're going to look at opposite over adjacent. Opposite over adjacent. Now, what are we actually talking about when we say opposite and adjacent? We're talking about the lengths of the sides, you guys. The actual lengths of these sides, okay? So and we'll talk about that in our problems today, but these are important to know. You have to remember them. So there's a little acronym that we know that a lot of people use. Not everyone, but lots. And you spell it like this. SOHCAHTOA. It is a key to remembering what the ratios are. Okay, so look, what this is saying is that the sine is equal to the opposite over the hypotenuse. Hypotenuse. Get it? See, so that's cosine. Cosine is equal to adjacent over hypotenuse. And then the last one is tangent is equal to opposite over adjacent. So SOHCAHTOA is a cool little way to remember, okay? But you have to remember how it's spelled, SOHCAHTOA, okay? I would highly recommend you write this whenever you do your problems. All right, so this is sort of like the beginner version of where we're going with this. There are also inverse functions that go with sine, such as they're called cosecant, secant, and cotangent. We're not there yet, okay? But there's a lot to learn. And we're just kind of doing like a sort of like a survey of trigonometry, but the expectation is by the end of trigonometry, if I give you a triangle and say I just give you one angle and one side, and it's right, you will be able to solve this triangle, meaning you will be able to find this side, and that angle. Okay? Or at the end of this unit, I should be able to give you two sides, and you should be able to tell me the third side and both angles. Okay, that is the goal. The cool thing about trigonometry, because we understand right triangles so well, we can use trig to solve triangles, okay? And solving is the goal. Solve means to find all angles and sides. So that's where we're headed. This is like the test. This is going to be like the test of this whole unit, okay? And this is the beginning. You need to memorize this. You can do this instead if you don't want to memorize this way, okay? Again, so, toa. Okay, so just so you know where I'm getting it. So here we go. Here's the notes for today, okay? So take a look at this triangle. It says sine, cosine, and tangent ratios, okay? Numbers for side lengths. So they've given you numbers. A right triangle has a side lengths. Okay, they always just explain what's there. They want you to find cosine, tangent, and sine. So cosine of A. A is telling you where to stand. So you come over here to the triangle and you're like, oh, there's A. This is where I stand. Here's where my eyeball is. My eyeball is right here. Okay, that's my lashes. Okay, that looks like a turtle or something on the side, but whatever. It's an eyeball, okay? So cosine is equal to, again, write this down. So, toa. So cosine is equal to adjacent over hypotenuse. So we stand here and adjacent is 15 and the hypotenuse is 17. So the cosine of A is 15 over 17. And that's it. Okay. Tangent. Tangent of A. Again, A is telling us where to stand. So we're back here at A. And tangent is equal to opposite over adjacent. So opposite you can draw the arrow to, and I highly recommend you do that. 8 over 15. It helps. I promise you, if you draw the triangle and you draw the arrows, it will help you absorb it and memorize it. Lastly, sine of A. Sine is opposite over hypotenuse. Opposite is 8, hypotenuse is 17. And those are your 3 answers. If you can do these by yourself, okay? I'm going to go ahead and answer them, hoping that you paused it. 3, 4, 5, okay? Cosine, it wants cosine of x, okay? So, toa, okay? Cosine is adjacent over hypotenuse. X tells us where to stand. Now we're standing here, okay? So this is us. We're looking out this way. Okay, cosine is adjacent over hypotenuse. We'll identify the hypotenuse. That's hypotenuse. Okay, so which one is adjacent? It's not the opposite. It's the 4. So it's 4 over 5. Sine of x is equal to opposite over hypotenuse. So opposite is 3, hypotenuse is 5. Tangent of x is equal to opposite over adjacent. So opposite is 3 and adjacent is 4. And that's it. Those are the values. Okay. Again, I did it differently because now you're standing at M. We want to find cosine M, sine M, and tangent M. Okay. So we're standing right here. Okay. Cosine M is equal to, so, toa. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. 8 over 17. Sine M. Sine M is equal to opposite over hypotenuse. 15 over 17. Lastly is tangent of M, which is opposite over adjacent. 15 over 8. Normally, by the way, we don't usually leave these as ratios. You were leaving them as ratios today. But when we actually find these values, we will take them out to the 10,000th. All right. Now they're going to put variables. So you're going to have to just kind of deal with this in that the sense of F is just saying F is how long this side is. D is how long this side is. And E is how long this side is. Okay. X is where we are standing because it says find the cosine X, tangent X, and sine X. So ready? Here we go. I'm going to change colors because cosine of X is equal to, so toa. Okay. Adjacent over hypotenuse. Here I am. Adjacent is D over hypotenuse E. Tangent of X is opposite over adjacent. So opposite over adjacent. Opposite is F. Adjacent is D. And then sine X is opposite over hypotenuse. Opposite is F. Hypotenuse is E. And that's it. You're just using letters. So in the beginning, it's just, can you see where you're standing and can you make these ratios? So now we're going to be standing at the top here because here's our x. So now we're here and we're looking down. Okay, so now this side is opposite, this side is adjacent, and this is still a hypotenuse. So when we go tangent of x, SOHCAHTOA, opposite over adjacent b. Cosine of x is SOHCAH, AH. It's adjacent b over hypotenuse a. Sine x is opposite over hypotenuse c over a. And those are the ratios. That's a really big lesson. Okay, here's one more. Okay, standing here at x, pause it if you want to check it out. First, identify your sides. Okay, for me, the easiest way to do this is, okay, so that's my hypotenuse, that's my opposite, that's my adjacent. The curvy line is my adjacent, opposite is the straight arrow, and I circle the hypotenuse. You ready? SOHCAHTOA. I used to have a teacher that would say SOHCAHTOA, but honestly, that doesn't help. SOHCAHTOA. And then I used to make this fairy tale up with an Indian girl named SOHCAHTOA, but then I was like, didn't know how to finish the story. So then I'd always make her die in the river, which was kind of sad. So here we go. Sine is opposite over hypotenuse. Sine x, opposite a over hypotenuse c. Cosine of x, adjacent over hypotenuse, b over c. And tangent of x is opposite over adjacent. All right. Now you're going to be using a calculator. There's nothing really exciting about this except for that now you're going to learn what this tangent, sine, and cosine are. Tangent, sine, cosine. So before we put the ratios like this, now we're actually going to let the calculator tell us what that is. Okay, 15 divided by 17. So these values are very fixed. So the tangent of 56 degrees in a right triangle is fixed. All of these are with right triangles, by the way. So here we are. Let me see if I can grab this and pull it to the side. Can I? Come here, honey. It doesn't want to come with me. Okay, that's okay. So tangent of, what is it? Tangent of 56 degrees. So tangent 56 equals. Okay, and it probably says to round it to the nearest 10,000. No, 100th. Oh, that's unusual. Okay, nearest 100th. Okay, so you would go negative 0.61. Okay, negative 0.61. Can tangent be negative? Yes, it can. Okay, sine of 69. So you're going to go sine 69, negative 0.11. Okay. And then cosine of 24. So all of this is just about plugging in, finding the buttons that say sine, cosine, and tangent, 0.42. And I guess rounding, okay, 0.42. All right, I don't think I really need to do this. You guys, all you're going to do is plug them in. All right, next. All right, so now we're going to be using the Pythagorean theorem to find a trigonometric ratio. Okay, we want to find what? Tangent of theta, where theta is the angle shown. So here's theta, okay? Give an exact value, not a decimal approximation. That means leave it in a ratio form. Exact means don't get decimals, okay? All right, well, here's the thing. They want tangent. Well, look, tangent of theta is equal to opposite over adjacent. Well, look, we don't have the opposite, so how are we going to get it? Well, we have a right triangle, so we can use the Pythagorean theorem. A squared plus b squared equals c squared. 9 squared plus b squared equals 10 squared. B squared is equal to 10 squared minus 9 squared. Do you see what I did there? I left it as a square. I'm hoping you guys can see what I did. I didn't solve it. You could do it. You could have just done 81 and 100. That would have been fine. And b is the square root of, because we take the square root of both sides. You guys, to undo the square, we have to take the square root. 10 squared minus 9 squared. Actually, you know what I'm going to do, you guys? I'm going to actually work it out. Sometimes with your calculator, you just want to plug it in. But because we're doing exact values, I think I'm going to do it this way instead, by hand. So b squared is equal to 81, 19. 100 minus 81 is 19. So b is equal to the square root of 19. Yeah, that was way better. Okay. The square root of 19. Yeah, if you're doing exact values, it's best not to use the calculator because then you're just going to get decimals. So the tangent of theta is the square root of 19. So look here, it says find sine of theta. Well, you're going to be missing something. You're missing that third side. And notice, same triangle, different ratio. But we now know that the b, oh wait, I did tangent. Tangent's opposite over adjacent. I forgot to put the adjacent there, you guys. See, opposite is the square root of 19. Okay, that's the answer. Square root of 19 over 9, opposite over adjacent. Now they want the sine. So you would use Pythagorean theorem, same one as we did there, and then you get the square root of 19. So the sine of theta is equal to opposite over hypotenuse. The opposite is the square root of 19, and the hypotenuse is 10. There you go. Next. Okay, see this? That's new. All right. Okay, give exact values, not decimal approximations. Okay, which means I have to go back and teach you about the next 3 ratios, okay? So here we go. I'm going to add this to your notes. Okay, I'm going to come over here. We have names for the inverse functions, okay? And the inverse of the sine is called cosecant. The cosecant is going to be the hypotenuse over the opposite. The cosecant is exactly the inverse. Look, it's the reciprocal of sine. Okay? Cosine, the inverse of cosine is secant. And that's going to be C over A. And the inverse of tangent is called cotangent. And that is C over B. Okay. We represent this. We can't write that whole name because we don't want to do that. So we put CSC of theta. Secant is SEC. And cotangent is COT. All right. What you need to know is that they are inverses of each other. What that means is that if you take sine and you multiply by cosecant, you're going to get 1. You see that? See how that B over C times B, C over B would equal 1. For you, for today, all I want you to do is try to memorize these things, the names. And look, it's counterintuitive. You would think S would go with S and C would go with C, but it's the opposite. The sine that starts with S, the inverse is cosecant. The cosine that starts with C, the inverse is secant. See, S goes to C, C goes to S. It's counterintuitive, and cotangent's obvious. Okay, thank goodness, right? Oh my goodness, thank goodness something is obvious. All right, there's a lot of different relationships, but for today, I think we're just going to need to know that secant of theta is equal to the inverse of sine, okay? So we need to find sine. Okay, secant is if sine is opposite over hypotenuse, secant is hypotenuse over opposite. Okay, so here we are at theta, and we need the hypotenuse, dang it. We have the opposite, but we don't have the hypotenuse. So you're going to use a squared plus b squared equals c squared. So you've got 3 squared plus 8 squared equals c squared. 9 plus 64 equals c squared. 9 plus 64 is 73 equals c squared. So c is equal to the square root of 73. And you guys, we can't simplify it like we did yesterday in class. 73, I believe, might be just prime. So this is the square root of 73. I highly recommend you copy these triangles down. And now it says find, oh, it didn't say the secant, you guys. It says cosecant. Well, boo on that. Oh, wait. Oh, my God. Look what I did, you guys. I hope some of you guys saw that I screwed that up. Do you see this? I called it secant. It's not secant. That's the cosecant. I have the idea right, but I named it wrong. The cosecant, I don't know why I put secant, is related to the sine. If sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Okay, so cosecant is equal to hypotenuse over opposite. And there you go. Okay. That's not all it asked for. It wants tangent. Tangent is equal to opposite over adjacent. So we're at theta. Opposite is 8, adjacent is 3. Then they want cosine. Cosine of theta is equal to adjacent over hypotenuse. And this is going to get a little tricky here, you guys. Adjacent is 3, right? Look. Boop. Hypotenuse is the square root of 73. I don't think they're going to let you leave that radical in the denominator. So we need to rationalize. I know I went over this in one of the notes. The denominator. And you do that by multiplying it by the square root of 73 over the square root of 73. So you get 3 times the square root of 73 over square root of 73 times the square root of 73 is 73. Please don't multiply those and then take the square root again. Some people were doing this yesterday, and I think this might help some of you. 73 squared. 73 times 73 is 73 squared. And then these two things undo each other, and you get 73. Okay. All right, let's try the next one. And this is the last one. It wants secant, cosine, and cotangent. Okay, so you need to reference your paper and figure out what they are. Secant is related to cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. Cosine of theta is equal to adjacent over hypotenuse. And lastly, the cotangent of theta. Okay, if tangent is TOA, SOHCAHTOA, it's opposite over adjacent. So, oops, my bad. I was telling you what tangent was. If tangent is opposite over adjacent, then cotangent is adjacent over hypotenuse. Well, we need the other side. We don't have this one. We know where we're standing because we have theta named. So you're going to have to go a squared, call this a squared, plus b squared equals c squared. A squared plus 9 squared equals 10 squared. A squared plus 81 equals 100. A squared equals 19. A equals the square root of 19. Do not get decimals, get exact. So now this is the square root of 19. So the secant is hypotenuse over adjacent. So that becomes 10 over the square root of 19. But you can't leave it like that. So you have to rationalize the denominator. Square root of 19, 19 squared cancels out, and you just get 19. I'm hoping that helps some of you guys not make the mistake. Okay, and you get, sorry guys, I'm just going to write that. Okay, I'm going to do it like this, 10 square root of 19 over 19. Adjacent, square root of 19 over hypotenuse, 10, and you're done. Cotangent is adjacent over, wait, what did I do here? It's adjacent over opposite. Oh my God, I hope you guys are catching my mistakes as I do these. Cotangent, look at opposite over adjacent is adjacent over opposite. I don't know why I put hypotenuse there. Okay, adjacent, square root of 19 over opposite 9. And those are your ratios. There's 6 common trig ratios that we talk about. And that's it for today.